does it look like to have an unbalanced force then on a graph? So, a graphical representation of an unbalanced force is any graph showing acceleration. Because if an object is accelerating, it will have a force being exerted on it, regardless of its mass. So then we have to think back to our kinematics unit. So we will be using some of our kinematics. So here, say if I have a displacement versus time graph, what does the displacement versus time graph look like if an object is accelerating? No, not straight. It will go like this. Close, though. The next one will be straight. Now, if I have, instead of velocity time graph, an increasing velocity with time, that will be a linear relationship. And an AT graph, an acceleration, it will just be a straight line showing where it is at what magnitude it is accelerating. There we go. Okay. So when a force is exerted in the same direction as the object is moving, the object speeds up. So this is like our acceleration kind of stuff. So say I have an object, and the object is moving in, say, the positive direction. If a force is exerted on it in the same direction as its original movement, so that's like, say, a car is driving that way, and then you exert a force by putting on the gas, you will accelerate which way? Same way, right? Okay. So this will equal speeding up, which is acceleration. But when a force is exerted in the opposite direction, it will slow down. So if I have my object, it's traveling this way. If I exert a force in the opposite direction, that's like putting the brakes on it. So it's pushing it back to go the other way. Okay? So then that would equal slowing down, which is deceleration. Next page. Okay, so let's try a couple examples of how we would be using this type of formula. So let's say here, object has a net force of 640 newtons acting on it. If the acceleration of the object is decreased by a factor of 9, and the mass of the object is increased by a factor of 2, what is the new net force? So we're not given a lot of data of what things are, we're just told how much it changes by. So anytime you have a question like this, you must set it up like this. You have your original, and then you have your modified. So what you change. It's very, very important that you pay attention to how to approach this, because you'll have to do it all through Physics 32. Okay? So an original, so what you just put down everything that was at the beginning. So you knew that it had an F net of 640 newtons. And we're just told that it's an object. So I know the mass of my object is just m. I can't say it's m equals 10 kilograms or anything. It's just m. And then I know it must have an acceleration. I don't know what it is, but I know that it is a for acceleration. If I put this together in a formula, I know my F net is equal to m times a, which is equal to 640 newtons. That's all I know. That's all I know right now. So that's just what we have to start with. So that's just the first sentence. I was just here. Okay, that's just the first sentence. But then it tells us that there's modifications now. It says if the acceleration is decreased by a factor of 9, so that means now I'm going to call this my A prime, and prime meaning like after. Okay, so the comma or thing that I put there, that's a symbol called prime that means after. Have you seen that before? In any classes? Math? No? Okay, does that make sense? So this is A prime, this is A. See the difference? This means after, modified. Okay? So A prime is A divided by 9, because it said that the acceleration decreased by a factor of 9. So factor means either multiply or divide. And it decreased, so I need to divide. So A prime, I took my original A and divided it by 9. What else changed? Well, my M increased by a factor of 2. So M prime, meaning M after, is equal to 2 times my original M. I'm going to just use different colors for that to show you. Okay. And it says, what is the new net force acting on the object? So that is F net prime is my question. I don't know if I gave you enough space here. Do you guys still have some space for writing things? Okay, good. Apparently I ran out of space. Okay, so now what we do is we write out what we know about F net on this side. So we write out F net prime. It's equal to M prime times A prime. Now I'm just going to keep writing below here. So I'm just going to keep writing. Is that okay, you guys? Okay, so now I'm going to substitute in what I have for M prime and what I have for A prime. So F net prime is equal to 2M times by A over 9. So do you see that? I took this and put it here, and I took this and put it there. Yes? Okay. So now what the next step that you do, you think to yourself, is you put all of the numbers together and you put all of the letters together. Okay? So we take F net is equal to, so I'm going to keep the letters together, M times A, and keep the numbers together, times by 2 over 9.
Would it be F net prime?
Yes, thank you. Now look, we can actually solve this, because here, I'm going to use red, this is the exact same as this. See that? We know this means 640. So now I can take this number and substitute it in right there. So I can write this as F net prime is equal to 640 newtons multiplied by 2/9. So 142.2 newtons, yeah? So to sig digs, F net prime is equal to 142 newtons. That's our final answer. So whenever you're not told like the numbers of stuff, you're just told how much it changes by. You always set up that original versus modified, okay? You figure out everything that you can, and then what you want to do, your goal is to substitute in something that you know from the other side. Okay? All right. So we'll be practicing that type of a question throughout the unit and throughout Physics 32, okay?